Good morning, everybody. Hope everyone had a great day yesterday and was able to do some math. I hope these videos are helping you. I know it's not the same as being in the room, but trying to make sure that you guys keep up with your studies so you're ready for 6th grade. That's my main concern. So let's get started. We're going to go over page 435, which was ordering decimals. I drew my number line here. So I have 0, 5/10, 1 whole, 1 and 5/10, 2 whole, and 2 and 5/10. So the first one is 1 and 9/10. So 1 and 9/10, well, you know it's going to be past 1. And 9/10 is greater than 5/10. So I'm going to put it about right here. So 1 and 9/10 would go right there. Number 2 is 284 thousandths. That is going to be a little bit more than halfway here. Probably about right there. 284 thousandths. Number 3 was 1 and 899 thousandths. So 1 and 899 thousandths would be close to where we just put this one. I'm going to make it down here a little bit. There we go. And 16 hundredths. 16 hundredths. So it's going to be less than this one because if we looked here and we did this, 284, 16 hundredths, we would see that this is 2, this is 1, so of course this is less. So we're going to have to put that, we'll try to stick it right here. Actually, you know what? Let's move that over just a tad. Because there we go. Sounds good. 235 thousandths. See, it's a good thing we moved that over because that would be 235 thousandths. All right. And then we have 773 thousandths. Which would probably be, if this was like 6, 7, 8, 9, 10, so we can put it right about here. All right. 821 thousandths. And 2 and 45 thousandths. So 2 and 45 thousandths. We can put it right over here. 492 thousandths. 492 thousandths. So that's going to go on this side of it. 492 thousandths. Sorry about the reflection. 2 and 16 hundredths. 2 and 16 hundredths. We can put it over this way. 2 and 492 thousandths. 2 and 492 thousandths. And 1 and 3/10. 1 and 3/10. So it's going to go over here. Here's 1. This is 1 and 5/10. So we're going to put it a little bit past the middle. All right, so hopefully you had success with that as well. All right, so let's go on to the other page we had to do yesterday, which dealt with more of our multiplication. And you guys are probably wondering, why is this multiplication, right? Why is this, doesn't seem like we're multiplying, but we really are. Remember, multiplication is repeated addition. It's making groups in a way. So let's see what we're going to do. Cycling and running. The astounding race is a bicycle race that is 100 miles long. Lords! is going to ride in the monster bicycle race, which is 2 4/5 times as long as the astounding race. So for number 1, we're basically coming up with the equation of 2 4/5 times 100. So this is a whole number, right? Because this is our mixed number, so it's a whole number. So we're going to do 2 times 100. We get 200, of course. And then we're going to do 4/5 times 100 over 1. Because 100 is a whole number, we put it over 1. We get 400 over 5. And that goes in there 80 times, right? So we're going to add these two together. So it's 200, our answer from here, plus 80 equals 280 miles. So Lords is 280 miles. Martin is going to ride in the Great Bicycle Race, which is 7/10 as long as the 100-mile astounding race. How long is the Great Bicycle Race? So here we don't have a mixed number. We just have an equation of 7/10 times 100. We're going to go ahead and put 100 over 1, and we get 700 over 10, right? And this is, of course, an improper fraction, so we divide 10 into 700. 10 goes into 77 times with a 0, so we end up with 70 as our answer, and it's 70 miles. Number 3, Samantha is training to run in a long-distance race. She runs 1 1/3 miles every day for a week, which is 7 days. How many miles does she run in 1 week? So we have our 1 1/3 times 7 is our equation. So we're going to start with our whole numbers first. 1 times 7 equals 7. And then we're going to do 1/3 times 7. We'll put that over 1. And we get 7/3. Now this one's a little trickier because 3 doesn't go into 7 evenly. So let's go ahead and divide. We get 2. 7 minus 6 is 1. So this 2 comes down, becomes our whole number. This 1 here becomes our numerator. And 3, which was our denominator, stays our denominator. But now we got to add this and this together. So we're going to do 7 plus 2 and 1/3, and we end up with 9 1/3 miles. Okay, and we'll come over here for some clean space for the 4th one. It is 7/10 of a mile from Nora's house to the library. 1 week, she biked the distance 8 times. How many miles did she bike in 1 week? So, of course, our equation, which it asked us to do, was 7/10 times 8, right? And we're going to put 8 over 1, and we end up with 56 over 10. Now, we have to divide 10 into 56. It goes in there 5 times, of course. We subtract, we get 6. So the 5 comes down and becomes our whole number. This remainder here becomes our numerator, and the 10 stays our denominator. And if you wanted to be really cool, you could reduce that to 5 3/5 miles. Awesome. Awesome job. So, and before I go on, I want to thank everybody for playing Arcademic. Someone was pretending to be Mr. E2. I would like to know who that is. They were pretty good. They must have learned from me, the awesome Mr. E. But it was a lot of fun. We'll do that again. So hopefully we'll get more people to join us, and then you guys can create games, and we'll just use the same password, and we'll just keep joining each other's games. Our student of the day here is Andrew. Andrew is our student name of the day, so make sure you leave that as a private comment. And now we're going to go on to another minute or so of what we're going to do today. So you're going to do page 442 as part of your work today. And you're going to do page 440. So 440 and 442 today. We'll change it to 442. So we've been multiplying whole numbers by fractions and mixed numbers. When we started, some of you weren't sure that these were really multiplication problems. I'm curious what you guys are thinking now. What makes these multiplication problems? So go ahead and leave a comment. It doesn't have to be private if you want to leave a comment on what makes these multiplication problems. And we'll talk more about that as we go along. Leave me a message. Email me if you're having trouble with stuff. I can help you. We can work together. I want to make sure everyone's really understanding this, and not just the steps, but also the reasoning behind it. So I hope you guys have a great day, and I'll talk to you soon.